By June 2026, our digital evolution is moving at light speed, but it is violently colliding with Earth's physical limits. We are forcing massive, next-generation AI workloads through aging, rusted infrastructure. That tension snapped this week when the hacking group ShinyHunters exploited a critical zero-day vulnerability. By targeting an unauthenticated remote code execution bug, known as CVE 2026-35273, they bypassed security measures and breached over 100 universities, stealing academic and financial data from millions of people. The hackers didn't use bleeding-edge quantum decryption. They simply walked through the front door of Oracle PeopleSoft, an enterprise resource planning software from the 1980s. Organizations kept using this legacy code because replacing it was deemed too expensive. Holding on to that technical debt is now an active threat. Success in this environment requires massive companies to abandon these outdated systems and radically rewrite the rules of physical infrastructure, energy generation, and capital markets. The most immediate physical limit we face is energy. Training large language models requires 100-megawatt data centers, drawing as much power as a small city. Terrestrial power grids simply cannot generate enough electricity. To bypass the grid entirely, Elon Musk has initiated the Gigasat plan. By 2030, SpaceX intends to launch 1 million AI-equipped satellites into low Earth orbit to process heavy computational workloads directly in space. On the ground, data centers waste up to 40% of electricity on air conditioning. In orbits near absolute zero vacuum, satellites use passive radiative cooling to shed heat, absorbing uninterrupted solar energy without weather delays. Deploying orbital server farms eliminates our atmospheric and grid constraints. Moving data centers to space offers a physics-based solution to Earth's energy crisis. While SpaceX looks outward, Apple is solving the compute bottleneck by shrinking it. With their third-generation foundation models, Apple runs complex AI directly on the iPhone's A18 and Mac's M4 chips. This edge computing approach bypasses the cloud to keep user data securely on the device. This graphic illustrates the model distillation process Apple used. Instead of building massive networks from scratch, they collaborated with Google. Massive Gemini models act as teachers, filtering their core logic down into Apple's highly efficient, sparse 20 billion parameter models. Combining Google's raw infrastructure with Apple's hardware optimization demonstrates that digital privacy relies on shrinking artificial intelligence until it fits entirely inside our pockets. The bottleneck extends beyond server space and into physical manufacturing. Designing a functional jet engine or a dense microchip requires massive teams of human engineers spending months drawing, testing, and revising. Jeff Bezos has returned to the CEO role to eliminate this exact delay. His startup, Prometheus, just secured $12 billion in funding to automate physical engineering. This workflow shows what Prometheus calls an artificial general engineer. The system generates thousands of candidate designs, simulates their performance using computational fluid dynamics, evaluates the physics, and immediately outputs an optimized version, completely without human intervention. Artificial intelligence is now engineering physical matter, optimizing hardware designs with a speed and precision that human engineering teams cannot sustain. Building this level of physical infrastructure requires trillions of dollars in upfront capital. The traditional problem is that private equity markets are notoriously restricted, making it nearly impossible for investors to easily buy and sell shares in pre-IPO hardware companies. Citigroup's digital depository receipts solve this. By custodying traditional shares and issuing substitute tokens on a regulated blockchain, Citi creates immediate liquidity. This tokenized scale enabled SpaceX's historic IPO, achieving a $1.77 trillion valuation, the largest public offering in history. Investors poured money into this offering during a period of broad economic uncertainty because SpaceX proved it could be highly profitable. Starlink's massive satellite network provides recurring internet revenue to more than 3 million subscribers, funding capital-intensive projects like Mars missions. Space exploration and advanced hardware are no longer restricted to government defense budgets. They are highly liquid assets actively driving the public financial markets. We have reached a critical consolidation point in June 2026. Computing power spans from our pockets to low Earth orbit. Artificial intelligence is autonomously manufacturing physical objects, and vulnerable legacy software is being purged to make way for rapid, blockchain-backed finance. But scaling this rapidly introduces existential risks. Launching 1 million satellites heightens the threat of Kessler syndrome, a scenario where a single orbital collision triggers an uncontrollable chain reaction of high-speed debris, rendering near-Earth space completely unusable for decades. Governments are also waking up to a stark geopolitical reality. Private megacorporations now command and control critical planetary infrastructure, from global internet routing to space-based data centers, capabilities that were previously reserved entirely for global superpowers. In 2026, technology is no longer a layer on top of our world. It is the physical foundation of it. Navigating this reality requires more than just capital. It requires a willingness to abandon legacy thinking in favor of the harsh, efficient logic of physics.